place. We stopped at this place where we included our own IP address of our device as the IP address through which the MQTT data should be forwarded to. So, if there's a device who's using MQTT protocol, that device will be transmitting their data to this IP address, right? So, so currently my IP address is this one. So I can find that using by typing ipconfig in the command prompt. So basically I can find my IP address, and it is this 192.168.4.234. So my IP address is this one, and if I put that in here and click this connect button, then I will not be able to connect to the server. I mean, the data that I receive to this IP address will not be forwarded to the MQTT server that I set up in my own local computer, right? So in that case, I have to follow an additional step of configuring where I forward the data packets which are sent to this IP address to another IP address, which is 127.0.0.1, which is the loopback address, and forward that data to that IP address. And the port will remain the same. So the port for MQTT protocol will be by default 1883, right? So that is, I think, what we tried to do in the last class. So we need to go ahead from that point. However, like I think that if you are not familiar with the MQTT protocol, I think I will explain about the MQTT protocol a little bit, and then we will try to try to connect the communication properly, so that the data that is received through the MQTT protocol will be sent to our server, right? So if you have any questions, please let me know, right? So we will talk about the MQTT protocol. Right. So we started, talking about this protocol under the physical design of IoT part. So under physical design of IoT part, we discussed about the IoT protocols. So these IoT protocols are required for us to implement an IoT network. So when we talk about the protocols, they are defined under different layers. So we discussed about the physical and data link layer protocols, then about the network layer protocols, transport layer protocols. Finally, we started talking about the application layer protocols. And first of all, we started talking about this MQTT protocol. So MQTT stands for Message Queuing Telemetry Transport Protocol. So this is the first protocol that we'll be discussing. And then we will be talking about other protocols. COAP, HTTP, WebSocket protocols. So these protocols, such as COAP, it stands for Constrained Application Protocol. Constrained Application Protocol. So that one also we will learn in the next sections of this module. First of all, talking about the MQTT protocol, right? MQTT protocol is as I think previously mentioned, is specific for IoT based applications and for low latency communications and reliable communications. So we will learn about those performances of MQTT. However, in standard, MQTT is known as a suitable protocol for IoT applications. So that is the reason that we are studying MQTT protocol specifically, and discussing a lot about that protocol. So when we look at MQTT implementation in the real life, we can implement MQTT using ESP32 microcontrollers. So I will show you the website that we can actually refer this protocol and implement that communication using two ESP32 microcontrollers. So basically, this is the website. That you can refer. So I will put that link in this chat as well. So we discussed about this during the interactive class we had last week. So we have basically this network setup that we need to implement that can do the communication from one ESP microcontroller to another ESP microcontroller. Right. So when we take MQTT protocol, one device will act as the publishing device. Like one device can act as either a publishing or subscribing device. That means that it can do both functions. It can do either one of the functions, or it can do both functions if it defines that in its own code. So it needs to inform about its state to the MQTT broker. So MQTT broker is the main specific feature in the MQTT communication. MQTT broker is kind of a feature that we can see in MQTT protocol than in other protocols. And other protocols such as COAP that I mentioned before, and HTTP, WebSocket, right? In those other IoT protocols that we are going to discuss and other main protocols, we do not see this MQTT broker in place. So MQTT broker is a special component which collects the data from its connecting devices and keeps like a database of data in its storage, specifying like the data such as specifying the topics of the data. That means like topics means like it could be something that is defined by the publishing device, right? So the publisher defines specific topics. So those topics are stored in this MQTT server. And then the receiver or the subscriber of a certain data has to subscribe to that certain topic. So if there's a topic called hello, let's say, right? There's a topic called hello. So the receiving subscribing device will subscribe to the topic called hello. So whenever certain data under topic hello is received at the MQTT broker, the MQTT broker will forward that data to the subscriber. And there could be multiple subscribers who are subscribed to the same topic. right? In this scenario, we only have one subscriber, but we can have multiple subscribers who are subscribing to a certain topic. Likewise, topics and data are stored in the MQTT broker. So when we are implementing this project, initially, the first step that you need to do is you have to set up the MQTT server. Right, so when you're setting up the MQTT server, you will have to install the Mosquito MQTT software. Right, so I think we discussed about the installation part in the last classes. So I think you must have already installed the Mosquito's MQTT server, softwares. And then once you have installed it, then you can run the commands in the command prompt and find out whether your Mosquito broker, that MQTT service is running or not. So MQTT server should be running, and you can check it by typing net start Mosquito. And if it is already started, it will show that it is already ongoing. And if it is ongoing, then you can see it also in the task manager as well. You can see under task manager, and you can check the running services. So you can check the running services, and then you will be able to see that there's a Mosquito broker here. The Mosquito broker is shown as running. Right, the Mosquito broker is ready in our own local device, right, and it is running, right? And then I told you that we need to have this software called MQTT Explorer, right? MQTT Explorer is a device, software which allows us to create the connection and allow us to see the data. So this is the user interface that allows us to see the data that is sent to the MQTT broker, right? So we can create the MQTT connection, and we can make the connection such that all the data that are sent to the MQTT broker are sent to this server and sent to this user interface. So in order for us to view the data, we need to connect our device, our server, the MQTT server in our local device to the data. We have to enable the data packets that are sent to the to our device, and receive the data that are sent for MQTT communication. So in that scenario, when we have this kind of error, then we need to forward the IP address of our local computer to the specific IP address, which is 127.0.0 20.1, right? 127.0.0.1. And we need to obtain that data through this 1883 port. So currently we cannot directly connect our MQTT server with this IP address. So this IP address is an IP address that is assigned to our device, our local device, which means our laptop, right? Our own personal laptop, through a certain router. This IP address is assigned by a certain router. This IP address can change based on the Wi-Fi access. If the Wi-Fi router changes at some point, then this IP address will change. And whenever that change, we need to check that, and we need to make sure we change this IP address based on the updated IP address, right? So this IP address might not be the same IP address that is assigned to our personal device by the router in another time instance. So in order for us to solve this, we have to give some specific command in this command prompt, and this command is also available in the LMS. I have given you a link in the LMS, such which is in this link. I will put that link in the chat. Then you can just directly get the command from that. Sorry, you can get that command from this website basically, and follow the standard command that can be used to forward the data that is coming to a certain IP address to the network, I mean to the local IP address, which does not change over time. So this is the IP address that has been allocated to our personal device from the router. Then now we can put this in here. I don't know whether it was correctly pasted. We need to paste the IP address in the correct position in this code, where the listen address should be the IP address of your device, and then you need to keep the connect address to 127.0.0.1 and connecting port as 1883. So those things will be as given in the default. The only thing that you will be changing will be this IP address. Once you give this command, you will be able to run this one, and then again you can maybe try this out. Now see, already it has got connected, even though I think it is okay now. I think, see, already I can go into the MQTT server and I can see the data inside it. Inside this server, right? I can see a set of topics that are by default shown in this server interface. So basically, all these are actually some topics that have been defined by another device which has accessed our server, right? So actually we need to make this server more secure by adding a username and password. So in here we can give a username and password, right? And I mean, we need to set those things up in a proper procedure. There's a procedure to follow for that. You can, you define a certain password, and you can use some standard commands to define the password for this MQTT server. And once you give that, username and password, another device which tries to access this MQTT server will not be able to access this server anymore. So you can increase the security of the MQTT server by adding username and password. As for the moment, we haven't defined the username and password, and whatever the devices who want to, connect can even connect to our broker. And there are anyway some default topics and data related to those topics available in this server, and you can see those things. And also you can see how a certain topic can be defined in the MQTT broker. So in the MQTT broker, as I said before, there are topics, right? So topics under which we store the data. So the topic is defined using this certain standard, right? $sys /broker/load likewise. So if I go to some kind of any kind of a topic, right? So there are many topics. So until the point received in here, I have a certain topic, right? So the data in here that that appears under the word received under the topic which is given by this set of, words, right? Sys slash broker slash load slash messages slash received, right? So that would be the topic for this data that has been published here. So likewise, we can first set up this MQTT server in order for us to receive some data from another device such as ESP32 microcontroller. So once we have set up this MQTT server, then we can proceed with the next steps. If you have questions so far, I think you can ask. So the next steps will basically be about configuring the ESP32 microcontrollers, the code. So when I talk about the like algorithm development inside the ESP32, we can do it using C++ or MicroPython, right? So you can, C++ is the preferred language for the embedded system programming. So I think you have a module called embedded systems, which is also parallelly conducted to you. So I think in that you are learning about micro C and how you can use C++ or C language to code the algorithm in the embedded system. So I think that is also a great learning for you. And in this module, I don't mind you using any of these two languages. And regarding the IoT project, you can use any of these two languages, C++ or MicroPython. It depends on your preference. So for a beginner level person, or if you want to, if you feel that you can select the language that you prefer. Whatever the language that you feel comfortable with, you can use. So MicroPython is a beginner friendly language, and you can use that as well. So in here, actually, I'll be basically focusing on MicroPython, mainly because it is recommended for beginners who are doing, coding. And then since my IoT module is focusing on multiple different things, I will not be focusing on the programming part only. However, you need to know some sort of knowledge about these programming languages. You are not, I will not be able to put a lot of, time for programming. However, because of that, I think I will be focusing on MicroPython, which is a very, I think, beginner friendly and a very simple language. When we talk about C++, even that is also a very high end programming language, which is very popular for developing, codes in embedded systems and other applications. So we are trying to build this build this project. So we have already set up the MQTT broker, and now we are going to set up this ESP1 microcontroller. So ESP1 microcontroller will be publishing data to a certain topic, right? And the ESP microcontroller number 2 will be subscribing to the data in that certain topic. So in this module, in this explanation, I will consider that the topic that we are considering are basically like other two topics, right? We are going to consider not these topics, right? So in this example, they have considered the topic hello and the topic notification, right? For my example, I will consider about two other parameters as the topic. So the topics that I'm going to consider are basically one will be the temperature, and another will be notification. So basically, this is the code that is available in the website that I showed you before. So it is actually not something to be afraid of. And first of all, I think we will go one by one. So we will import the required libraries for us to run this code. So the libraries that are related to setting up the Wi-Fi connection and other things related to, the built-in functions of the ESP32, we will import the libraries. The first thing we need to do is we need to set up the Wi-Fi connection between the ESP1 microcontroller and the MQTT broker. So in order for us to set up that connection, we need to give the this command to the controller. We need to code this, and we need to set up the Wi-Fi connection first. So in order for us to, you can give the Wi-Fi name and the Wi-Fi password. For example, if you are using the SLTC Wi-Fi, you can give the Wi-Fi name. If you are using SLTC Learn, you can give SLTC Learn as the Wi-Fi name, and the Wi-Fi password will be the password of that Wi-Fi type, right? SLTC Learn. The password of SLTC Learn. And then MQTT server's IP address you have to give as the another input parameter, right? So MQTT server's IP address is what? What is the MQTT server's IP address in your case? Okay, so what would be the IP address of the MQTT server in the case that you are considering? In your own, when you're implementing on your own, what would it be? What should you put there, basically? Right? So basically, you need to put your own MQTT server IP address, which you have set up in your own local device, right? Your own laptop, it could be, right? Your laptop's IP address, right, which you use to set up the MQTT server connection. Right, in this case that I have considered, my IP address will be therefore like the IP address that I have got using the using the command prompt, right? So in the command prompt, I can observe my IP address, which is 192.168.4.234. And this is the IP address that I have used to connect the MQTT connection, right? MQTT communication. So this is the IP address to which somebody needs to send their data, right? If they are sending through the MQTT protocol, right? So this should be the IP address that I give in this place, and then rest of the things, it would be like this line with about the client ID. So which means that ID, the client ID is the ID that is allocated to the ESP microcontroller by the by the by the by the microcontroller itself. And there's some kind of a unique ID that the machine allocates to a certain microcontroller. That ID is what we call as the client ID. So the client ID is obtained using this command. And then we give two other like information such as topic underscore pub and topic underscore sub. So these are two variables that we define, which are used to define the topics, that are stored in the MQTT broker, right? So the MQTT broker has two topics in here in this situation, right? So these topics are temperature and notification, right? So I'm going to consider these two topics as the topics, right? So one thing is temperature, other thing is notification, right? So the topic to which I'm going to publish the data is temperature. The topic from which I'm going to subscribe, or the topic from which I'm going to take some information is notification, right? So in this scenario, I'm going to send temperature data to the topic called temperature, right? And then, right, there's also another topic called notification. And that notification topic is a topic that is actually, the data that is stored inside that notification will be input by the ESP2 microcontroller. ESP2 microcontroller published the data for the notification topic. And ESP1 microcontroller is basically subscribing to that notification to obtain any data that is inserted to the notification topic, right? So what happens here in this scenario that we are considering is that if there's some kind of a data that is like that ESP microcontroller number 2 is receiving, that ESP microcontroller number 2 is giving some acknowledgement to the notification topic saying that it received the temperature data, right? So the number 1 microcontroller will receive that notification by subscribing to the notification topic. So I hope it is clear in that sense. So what notification means is that notification gives the data that says whether whether the ESP microcontroller number 2 receives some data or not, right? So I hope it is okay and clear to you. So if it is not clear, you can let me know, right? And then another thing is that you need to initialize the Wi-Fi connection, right? Initialize the Wi-Fi connection. And in order to do that, you can use this code in the right side of this slide, right? So this part you can use to initialize the Wi-Fi connection. So basically you have to run this code, the ESP32, and see whether there's an output coming called connection successful. The connection is successful. That means you're connected to the Wi-Fi properly, and therefore you can actually initialize the communication between the ESP microcontroller and the server. And then another 3 parameters that we are going to initialize here is these 3 parameters, right? So these 3 parameters are parameters that are useful for our algorithm that we are going to build in the next slide, right? So these are initialization parameters, and we are going to talk about that in the next slide. So these are the codes that we are going to use to send to one thing is, right? So there are different functions that we are going to define. So this function is known as the callback function, right? The callback function is defined to act whenever there's some message received at the ESP microcontroller, for example, right? If a certain device that we are considering is receiving a certain message, then this function will be activated, right? Whenever there's a message received, then the message will be checked. This message, if that message contains the notification string and the received string, then the ESP1 microcontroller will print this one. So anyway, what we'll be checking here is that we will be checking both the topic and the data underneath the topic, right? So once those conditions are satisfied, the ESP microcontroller will print this statement. So basically you need to actually go through this topic, this code as well. right? I think by doing so, you can understand further. Basically, ESP1 microcontroller uh, will be checking these messages that it receives and check whether it receives some notification message, and it prints out some output if it receives such kind of a notification message. There's another function that is defined, which is known as connect and subscribe, right? Connect and subscribe function is a function that defines basically like the topics to which we have subscribed to, right? And like displays like the topics to which you have which the microcontroller has subscribed to, right? Then like in this code, basically we'll be basically defining, I mean, only the topic sub, right? So this code is something you will have to go through. So the main main operation that will happen through this code will be basically defining the topic to which this ESP microcontroller is subscribing to, right? The subscribing topic you are defining here. So apart from that, the main thing is starting here, where you will be running this algorithm, right? Where you'll be running this algorithm, where you will be publishing data of temperature, right? Temperature data to the MQTT broker. You will be publishing temperature data to the MQTT broker, right? And you will be so you will be doing the publishing using this client.publish command, right? Apart from that, you need to create the message that you're going to publish, right? The message that you are creating will be given in the first line before this, which is message, which is given in string format, and which is like you define string temperature and the value of temperature, right? So in here, percentage values means like it is a floating number. Percentage F means it's a floating number that you are giving as a temperature. And then you can define message in this format to show that you are going to publish a message that has temperature data and which has a value of the temperature, right? So earlier we saw that in this MQTT server explorer, that there are some data like 1 minute equals some kind of a data, right? 0.59, likewise. So in here, whatever the data that is published is this one. So this data shows that 1 minute is a constant number, right? 1 minute, all the time it is constant value. So you give it as a constant string. Then the value will change. The value will be a variable. It will be changing, right? So it changes constantly. I don't know whether you can see in here 1.17, it is changing by different times. It's 0.97 now. So that variable, it's a variable, and you need to define it as a variable in this place in the code. And that is defined using this placeholder percentage mark and F to show that it is a decimal number, right? So the temperature value will be denoted using a decimal value. Apart from that, once you have defined the message and you have defined like what you need to do, whether it's publishing or subscribing in here, you need to put those things inside a loop, which is inside the if condition, where you define the frequency in which the data should be published to the MQTT broker. So the frequency you can define as maybe as a value that you prefer. The frequency is defined using this parameter, message interval. So message interval value you can give as 5 seconds, 10 seconds, 1 minute. Likewise, you can give the frequency in which you want to publish the data into the MQTT server, right? So once this interval, is reached, this loop will publish the data. right? So what if condition does here is that it checks the current time and it checks the last message time, right? The time that the last message was sent. And if the difference between those times are like bigger than a certain message interval threshold, then it is going to publish the data, right? So the last message value will be changed each time as the current time value, right? Whenever we publish a data, the last message variable uh, will be defined as the current time. So current time we define as this time function. So the last message value will only change once we satisfy this if condition. And once you come here, then the last message variable will change and the counter variable will change. And these two variables are variables that we initialized in the first parts of our code, which I showed you in here, where you initialize the values of last message to 0, message interval to 5, counter value to 0. So these three variables you keep as initialization variables. So I think we discussed about the publishing part, right? So this part you can run, and you can run this without ending. You can keep running this, right? So while true is a loop that we are using here. So because this is a while loop, this will keep on running until we stop the code, right? So it will keep on running without stopping. Since there's no condition that is applied for us to stop the code, it will be while true means it will keep on going until we stop it manually and with the specific commands from our IDE, for example, or else by resetting we can stop the code. And then we also have this other command where it says at the end that restart and reconnect, which means that at points where we cannot connect to the MQTT broker, we need to restart the connection with the MQTT broker, right? So in order for us to do that, this specific function called restart and reconnect is defined, right? So this specific function is defined for restart and reconnect function. And that function is used to connect with the MQTT broker when you lose the connection with the MQTT broker. So this can be used for that in such scenarios. So, right. So basically, up after restart and reconnect, you can run this client connect and subscribe function to reconnect the devices and assign the devices as either subscribers or publishers, right? We can assign the devices as either subscribers or publishers to a certain topic. And then, right, so basically this is regarding the ESP microcontroller number 2. I think that you can understand how the procedure works for ESP microcontroller 1, right? So if you cannot understand, you can let me know. So far, if you have any questions, you can let me know, right? Please let me know if you have any questions. In the meantime, I will share with you the attendance OTP number. Please mark your attendance if possible. Okay, so proceeding further, we will, I will just, I will ask you to go through the code for the ESP microcontroller number 2. I think that you can try to learn on your own how we can set up the different parameters in here in comparison to the ESP1 microcontroller, and what are the parameters that change in here. So basically the code that is used for ESP2 is given in this slide. So ESP number 2 is basically a subscriber to the temperature data. Right? It is subscribing to the temperature data, and it is publishing to a topic called notification. So it is also a publisher. So it is doing both of the operations. So now I think I will go through these codes. You can search and learn, I think, the coding from your own end, which is, I think, something that you can learn from. So we will actually start discussing about another aspect of MQTT protocol. So this is known as the quality of service of MQTT, right? So MQTT protocol, right? MQTT protocol depends on the connectivity, right? MQTT protocol depends on the connectivity, and therefore, I mean, like whenever we are whenever we face some connection issues between the MQTT broker and the device, right? Could be the publisher, it could be the subscriber. Then we will lose the connection link with the MQTT broker, right? We will lose the connection link between the MQTT broker. Then in that case, like we need to have some mechanisms to re-establish the communication link and re-establish the data, or we need to resend the data back to the devices and receive the data from the devices as suitable. So in order for us to know like what is the level of reliability we need to maintain, we define something called the quality of service. So anyway, like whenever we lose the communication link between the MQTT server and the device, we need to set it up again, right? However, there are some instances where we do not have the, I mean, need to recover the data that we lost, right? In those cases, we use a certain quality of service level. So I think 2 students are asking for me to reshare the attendance tool. So I will share that. I hope you can see it now. So those students, if you have already marked your attendance, please put a message. Okay? Then I will proceed. Right. Are there any other students who are still waiting to mark their attendance? If right. So I think now it's okay. Great. We will discuss about this communication again, MQTT protocol communication. And if there's if we lose the communication between the device that is transmitted to the MQTT broker and like who's receiving some data from MQTT broker, so what is the level of reliability we need to maintain, right? What is the requirement in this application? So right, so what I mean is, like, for example, if we take a situation where we are monitoring some temperature of a certain environment, right, and that data is stored in this MQTT broker, right? Let's say that temperature data is measured every second, let's say, and then that data is getting transferred to the device, to the receiving device. And that receiving device, if it loses one data, right, in situations, if it loses one data, sometimes it might not really matter, right? Just data of 1 second, right? It might not matter for the receiving device. The receiving device might not need that data, right? So apart from that, if we take another situation where we need to ensure that every data that is sent to us should be received, right? All the data that is sent to us is crucial, right? So let's say that a certain mosquito or MQTT broker is sending some important data at a certain time interval. Let's say within, I mean, at each 30 minutes, it is sending some data to the device, to the receiving device, right? So at each 30 minutes, if that data is lost in between in the communication, then the receiving device will not get the data that it is expecting to get, right? And that receiver will lose the data, right? So the receiver will, will face some problem, right? Because that data was sensitive and that data was crucial for its own operation, let's say. So when that happens, we need to make sure that we establish the communication again and we resend the data that we lost back to the receiver, right? So in order for us to do that, we have defined three levels of quality, right? Three levels of quality levels, which I define here as basically 0, 1, and 2, right? 0, 1, and 2, right? So 0 level of quality is the least, or least expensive one, right? 0 means the least expensive one, and 2 is the most expensive one. What I mean by expensive is that we need to allocate more resources to implement the most expensive version of the MQTT, right? So if you take QoS level 2, then we need to put more effort to implement that protocol. So when we talk about those three levels of QoS, or the quality of service level, the quality of service level of 0, as I said, it is shown in this figure, right? And then this quality of service level depicts a scenario where we are sending data to the MQTT broker, and the MQTT broker does not need to provide any kind of feedback back to the publisher, right? Back to the device that sent the data. MQTT broker does not need to do anything, and the device who's sending the data or publishing the data need to only publish the data at certain time instances, and that is it. Not much of effort done. Not much of effort needed, right? So that is how QoS level 0 is maintained and it is implemented, right? So when you are implementing MQTT protocol, you can define the QoS level based on your preference, right? So I think in the MQTT Explorer also you can view that. So in MQTT Explorer also you can define the QoS level in the MQTT Explorer, right? In the MQTT Explorer, you can define I mean, basically you can define the QoS level in the interface as well. And in the communication also, you can, so in the MQTT broker, you can define what is the QoS level that you are trying to maintain for this communication. It can be 0, it can be 1, it can be 2. I hope you can see in this lower panel, you have specific place to define the QoS level, right? So those are the QoS levels basically. So you can check, you can select either this one, or third one, which is the QoS level 2. So depending on your application, you need to select the specific type of QoS level, or you can select the specific type of QoS level depending on your application, right? If you want to send multiple of data, and then you don't really care about, like data losing, then you can use QoS level 0, because sometimes the data that you lose will not be that much like important. I mean, you can bear with that consequences. You can bear with the consequences. However, if you use QoS level 1, then you will be implementing more functions. So in the QoS level 1, you will be basically publishing the data, and the MQTT broker will respond back to the device, and it will respond by using a certain message type called pewback, and that one will be used to give acknowledgement to the device, right? The MQTT broker sends some acknowledgement back to the device saying that the MQTT broker receives some data, and by doing so, the whatever the client will understand, okay, that specific data has been reached by the broker, right? So in order for us to maintain a certain reliability, we can use this kind of a scenario where we can ensure that our data has received the destination, right? And however, some problem in here is that we will be sending like duplicates of data until we receive some kind of acknowledgement, right? If we do not receive some kind of acknowledgement on time, then the publishing device will be sending data continuously until whatever the acknowledgement message is received. And thirdly, in the QoS level number 2, we have a different method of verifying the communication that has happened. So in that case, we have multiple functions. So as I said before, the most effort is taken in the QoS level number 2. So a lot of functions are defined in this stage. So basically, initially the temperature data will be published to the broker, and the broker will send a certain message saying that it has received the data back to the device, which is the client, and the client will release sending that data again, and that one also, that client will notify the broker about. And once that is received by the broker, then the broker will send another message saying that the total process is completed. So in this case, actually, this is for a case where we are trying to send some sensitive data to the receiver. So we want to make sure that all the processes have been completed, which means that the communication between the client and the broker has been maintained properly, and all the communication has been received by the broker. I mean, all the data has been received by the broker, and the device will get notified that that broker received all the data, And then now the client wants to end the communication. So in order to end the communication, it will first send that another, third message, which is known as pub rel, or that means publish released, and then that will inform the broker that the client will not send any data related to its own unique data again. The client will not send any data again with that certain ID, for example. And then the broker will send the last type of data, which is pub complete, which means that publishing has been completed. So this is for a very sensitive data, which we send in a situation where we only send one data at one time, right? So in a case where I want to send like very crucial data, I don't want to send it multiple times. In cases where I don't want that data to be disseminated into the public, for example, so this could be some secret or some kind of useful data which I don't want to send multiple times. I only want to send it one time. In that one time, I want to make sure all the data are received at the broker, and the broker confirms to me that it has received. Once it has received, once the receiving has been confirmed, then the client says again, okay, now I'm also completing everything. I'm not going to send that data again using the message type pubrel. And then broker will send another message saying, okay, everything is now completed. The process of communication has completed. So it will send the pubcom data. So that is basically regarding the QoS level number 2. So those are actually really, I think, important concepts regarding the quality of service, and we will talk about this in the next class as well. So I think with that, I will end today's class. So with that, I think if you have any questions, you can ask, and you can leave if you don't have any questions. And I would, thank you so much for joining today.